In this chapter, we're going to look at topics related to measurement. In this lesson, we're going to look at the volume of pyramids, cones, and spheres. All right, hi everybody, welcome. We're going to take a look at volume and capacity of pyramids, cones, and spheres. Okay, so the volume of pyramids, there's a really neat relationship that exists here, okay, and really clean between the volumes of prisms and pyramids, okay. If a prism and a pyramid have the same base and same height, so basically if the overall dimensions are the same, so just give you an idea of what that looks like here. Let's say you got your prism here, 5 inches by 10 by 5, okay. Let's say the corresponding pyramid that we're looking at has the same dimensions, 5 by 5 by 10, okay. Then what happens here is it actually takes 3 of these pyramids to fill one of those prisms. In other words, the prism here is 1/3 of the volume of the larger prism that you're working with, which is a really interesting relationship. It's interesting to me that it's such a nice divisor. Okay, we take the area of the volume of the prism, and we simply divide by 3. That couldn't be more beautiful. Just love it. So what we're going to do here is we're going to substitute the specific formula for the shape of the base in, okay? Because remember, the base of the pyramid could be a square, could be a rectangle, could be a triangle, could be a polygon here, it could be anything. And then we're going to multiply by the height, and that's going to be the distance from the center of that base to the apex. And then we just divide by 3 to get the volume of the pyramid. Okay? So now let's just take a look at some examples of how that works. Okay, so for this question here, it's a triangular pyramid, so we've got a triangle as a base. So the base formula is going to be length times width divided by 2, assuming we can see that clearly and we don't have to do any other work to get that. And then again, the height is going to be the distance from the center of the triangle up to the apex. So in the triangle that we're given right here, the height is going to be 5. It's the distance from the center up to the top here. So that's our height here. So we're going to have length times width divided by 2, multiplied in this case by 5, and then the whole thing is divided by 3. Love that. Now here, look at where the 90-degree angle is. That means in this triangle here, the base triangle, the length is going to be 4, and the height here is going to be 3. Okay? So there we go. Length times width, divided by 2, because the base is a triangle, multiplied by the height, and then the whole thing divided through by 3. So this is going to be 12 over 2 times 5 over 3. I'm going to just keep going here. 12 over 2 is 6. And then 6 times 5 is 30. Divided by 3 is going to be 10. So because we're looking for volume, this is going to be 10 centimeters cubed. All right, now in this question, we're looking at a square pyramid. So the base is going to be a square. So that's nice and easy. That means the area of the base is just going to be length times width, or side squared there. So the pyramid height is the distance from the center to the top. So now in this case, that height is going to be 6 feet. Okay, and so our volume is going to be the area of the base, which is just going to be side squared. So in this case, it's going to be 6 feet by 6 feet. So it's going to be 6 by 6. And then we're going to multiply by the height, which is another 6. So this is basically a pyramid that we're forming in a cube. But then we divide by 3. Okay, because remember the volume of the pyramid, the corresponding pyramid, is going to be 1/3 the volume of its corresponding prism. So 6 times 6 times 6 divided by 3, and we're going to get 72 feet cubed as the volume of that pyramid. Now in this question we're looking at a rectangular pyramid, so again the base is a rectangle. The area is going to be length times width for the base. So here, taking a look at our base, we've got 4 miles this way, 9 miles this way, so the area is just going to be the product of those two. The height is just going to be from the center to the apex, and so that's going to be 11 miles. This is a huge pyramid here. So our volume will, when we put that all together, we length times width of the base. So 9 times 4, and then multiplied by 11 for the height here. And then remember, because this is a pyramid we're working with, we're going to divide by 3. So now this is 9 times 4 times 11. Then we're going to divide the whole thing through here by 3, and we get 132 miles cubed, because we're looking for the volume. All right, so this question, a little bit more going on here, because this time we've got this regular polygon as the base here. And specifically in the case that we're looking at here, it's going to be a pentagon. So the base formula, remember, is going to be the length times width divided by 2 times the number of sides. So what we're going to do here is we're going to go from the center of the polygon out to the vertices here to create those triangles. And because this is a pentagon, we're going to have 5 of those triangles. Now it's not too hard to figure out the area of one of these triangles here, because we know that the side lengths will always be the same. So this base here is going to be 9. And then we're giving you the altitude, or the height. So our volume here is going to be, first of all, the area of the triangles, or the area of the base. The area of the base multiplied by the height, in this case from the center to the apex is 12, all divided by 3. So here are the pieces. So this is going to be the base, 9, times the altitude of that triangle at the bottom. Because remember, right now in this moment, I'm trying to figure out what the area of the base is. So divided by 2, because I'm working with a triangle. Multiply that by 5, and right here, this is the area of the base. Now we're going to multiply by the height, which is the 12. And then because we're trying to figure out the volume of a pyramid, not the prism, we're going to divide that by 3. So we pull out the calculator. So let me just move that over a little bit. So we're going to have 9 times 6.2 divided by 2. Multiply that by 5, multiply that by 12, and then we're going to divide by 3 to create the volume of the pyramid. Whoops. And I get 500. Okay, whoops. Sorry, I don't know why there was a little bit of a delay there. I hit it twice there. 558, not that last one. 558 kilometers cubed. Right, now in this question, we're going to find the volume of a cone. Now, the relationship is going to be basically the same. It's just that this time the shapes that we're comparing are a little bit different. So the base is a circle. Okay, we know that. We've looked at cones before here. And bear in mind that the cone is actually going to be, if you think of it in kind of a parallel sense to the pyramids we've been doing, the cone is being pulled out of a cylinder. But the relationship is still the same. The volume of the cone is going to be 1/3 the volume of the corresponding cylinder. So in this case here, we need the pi r squared. We need the area of the base. So the radius of the base is 9, so the area is going to be pi r squared. So that's okay. So pi times 9 squared. And then we're going to multiply through by the height. Okay, so that would be the volume of the cylinder. But then remember, I divide by 3. That's kind of that magic divisor here. And dividing by 3 is what converts this into the volume of the cone. So this will be pi times 9 squared multiplied by 18, and then divide the whole thing through by 3. Okay, and so to the nearest tenth, that's going to be 1,526.8 meters cubed, because we're dealing with volume. All right, now in this question, we're going to look at a sphere. Okay, the formula for a sphere is different. Okay, it's going to be 4 pi r cubed over 3. Now notice you still got that over 3 there, which is kind of cool. That pops up again. Is this kind of consistent division by 3 here? In any case here, it's pretty straightforward, because the only dimension that I need is the radius. In this particular problem, I've given you the radius. So it's 4 pi times 9.8, and that'll be cubed. Okay, that makes sense because this is a volume. It makes sense that we would be cubing our dimension here. And then we go to the calculator. So 4 times pi times 9.8 cubed Okay, and then we'll divide that by 3. And we're getting kind of a crazy decimal here, but that's because of the pi that's in there. So now this will become approximately 3,942.5 miles, whoops, I should say miles cubed. So if I put an m there all by itself, it looks like a meter, and I don't want that. I want that to be miles. And there you go. Okay, and finally, the last thing we want to look at here is a hemisphere. And the hemisphere is pretty straightforward because what it is just half of a sphere. Now, with the surface area formula, if you're trying to find the surface area of a hemisphere, it's half the surface area of a sphere, but then you have to add that exposed surface here that you get. So it's more than half of the surface area of the corresponding sphere, which is kind of weird when you think about it here. But in this case, the volume is really quite straightforward. It really is just half of the volume of the corresponding sphere. So the volume of the sphere would be 4 pi r cubed divided by 3, and then we're just going to divide that by 2. So in this particular case here, it's 4 pi 12 cubed divided by 3, so there it is. And then we're just going to simply take that and divide that by 2. So pull out the calculator here, and this will be 4, where is it, pi times 12 cubed divided by 3. So that's the sphere. And now what we're going to do is divide that by 2 to get the hemisphere. And what we're getting is it's approximately 3,619.1, and this is inches cubed. Okay, and so there you go. That's how you find the volume of these cones, pyramids, and spheres.